Okay, so on the solid, liquid, gas, foldable, 1, keep it shut. We're going to take some notes on the outside of it first. So on the outside, okay, on the outside, you should see solid, liquid, gas, solid, liquid, and gas. What do you notice about the pictures, Bryson, on the foldable? What do you notice about the pictures?
They all have, like, circles.
Okay, they all 3 have circles. What do you notice about the circles?
On solid, they're all together. They're all, like, smushed.
Like tightly packed?
Yeah, and then liquid, they're, like, a little apart from each other. And then gas, they're, like, really far from each other.
Okay. Do you think that is a representation that can help you remember how the particles are arranged in each of those states? Yes, that's kind of a visual for you. What we're going to write on the outside is how we get from one of these states to the other. So kind of like the stuff we just read in the book. So on the outside, leave your foldable shut. How do I get, and I want you to draw this arrow. How do I get from a solid to a liquid? What happens to get from a solid to a liquid? Lori?
It needs to be at its melting point.
Okay, so yeah, it has to melt. So I'm going to put melting out here. I'm going to try and write sideways. You guys can turn your paper. I can't. I'm writing melting. Okay? So yeah, to go from a solid to a liquid, it has to hit its melting point, or it has to melt. What do we call it if we're going from a liquid to a gas? This is one we didn't stop and talk a lot about because you're more familiar with it. Kendall? No, not. So that's what point it has to reach. But what happens when water is boiling? What happens to some of that water? And we're more talking about going from a solid to a liquid, it melts. To go from a liquid to a gas, what's happening? Maya? Evaporation is what's happening. Yes, evaporating. So I'll just write evaporation. I'm not being very consistent here. Evaporation. Evaporation. So to go from a solid to a liquid, something has to melt. To go from a liquid to a gas, it can evaporate. Let's go the other way. We're going to draw 2 arrows here. What do we call it when a gas turns to a liquid? My hot air hits the cold window. Brant, what do we call that? When a gas is turning to a liquid, my hot air touches the cold window. What forms? Dane? Condensation. Condensation. Okay, condensation occurs. And then from a liquid to a solid, Brady, what's happening?
Freezing.
Yes, it's freezing. Freezing. Okay, those are terms you're going to have to become familiar with. Like if I said, what has to happen for a gas to turn to a liquid? There has to be evaporation, or it has to reach its boiling point. There's different ways to say it. Okay, now open your flaps. We're going to do the solid first. We're going to talk about the shape, the volume, the arrangement of the molecules, and then give some examples for each one. So we have like 4 things we're going to put under each of them. That's why I went ahead and kept it kind of big. So open your solid flap. And how about on the inside? So on our notebook paper, we will we'll have 3 bullet points. So just try and space them out on through the whole thing. And over on the flap, like on the white side, we will write the example. So flip open your solid flap. We're going to do 3 bullet points on the notebook paper, and we'll write our examples on the actual back side of where it says solids. Okay, so let's start. With each one, we're going to talk about the shape, the volume, and how its molecules are arranged. Let's start with shape. What do we know about the shape of a solid? Definite or not definite? Maya? It has a definite shape. So let's write definite shape. If I could spell, that says define. Definite shape. In parentheses, we're going to put what that means. What does it mean if it has a definite shape? Haley?
It'll stay the same shape.
Yeah, it does not change. Doesn't change. Okay, we're going to say something about its volume. First, what is volume? Sadie?
Volume is like the amount of space an object takes up.
Yeah, the amount of space an object takes up. Thinking about a solid, and it's still going to be definite or not definite. Will a solid always take up the same amount of space, or will the amount of space change from time to time? Lori? Yeah, so it has a definite volume. Which again means it's not going to change, it's going to stay the same. I'm not going to make you rewrite it. And the last thing we're going to talk about for each one is the molecules. How are the molecules arranged in a solid? Max? You can use the front picture to help you. That shows the molecules. How are they? They're tightly packed. The molecules are tightly packed. So the molecules are tightly packed. Who can give me some examples of solids? And we're not going to, there's a million of them. Kendall, give me one. A brick. Nate, give me another one. One more. Brody, tell me one more solid. A what? Okay, a window. Okay, and again, we could give 800. We're going to stop there. Let's move on to liquid. So close that flap, open the next flap. Open your liquid flap. We're going to do it the same. We're going to do 3 bullet points on the notebook paper, and then we'll write some examples over on the flap, on the back side of our flap. We're going to hit the same thing, 3 things. So shape, volume, and molecules. I'm going to write those in. Shape, volume, molecules, and I'll slow down, let you catch up. What do we know about the shape of liquids? Reese?
Like the shape, like the shape is whatever the liquid is in.
Yeah, so it takes the shape of its container. So takes the shape of its container. So if it's in a tall, skinny container, it's going to look like a tall, skinny liquid. If it's in a short, stubby container, it's going to look like a short, stubby liquid. It takes the shape of its container. What about its volume? Brant? Yeah, it has a definite volume, which means its volume does not change. It may look different. Okay, but just like me, if I'm standing up straight versus balled up on the floor, I'm still taking up the same amount of space. I just look different. It's not like I got bigger or smaller. I just changed my shape and how I look. But I'm still taking up the same amount of space. Nope, I put define again. Darn it. That's what happens when I try and talk. Definite volume. Sorry. Molecules. Brady?
Glide past each other?
Yeah, so they glide or slide. I'm going to put both glide / slide past each other. Okay, and where solid molecules are very tightly packed and they just kind of vibrate in place, these ones, they do have a little room to move. They have a little room to move. So solids, they don't move. They just kind of vibrate in place because they're so tightly packed. They don't have anywhere to go. They cannot move. But liquids have a little bit of room to move. That's why they can glide past each other. Why are you packing up? Not yet. We're almost there, okay? We're almost there. You guys will need these notes for your homework. Okay, we have one more. Oh, examples. Maya. Water. I'm just going to list some. Water, tea, soda. There we go. 3 examples. Moving on to gas. Set it up the same. 3 bullet points and some examples. Shape, volume, molecules. Shape. Similar to a liquid. What does it take the shape of, Brant? It hasn't. It doesn't have a definite shape because it takes the shape of what? Reese?
It takes the shape of its container.
Yeah, of its container. Remember yesterday, if it's in our stomach, it's taking the shape of our stomach, but it's pushing out because those particles are trying to get away. When it gets to the bigger container, the vehicle, it takes the shape of the vehicle. Okay, till you open it up.
Miss Shilling,
Yes.
can you send Brant and Bryce down? Their mom's here.
Yep, we'll be down in just a minute.
Thank you.
Okay, hold on. We're going to finish this real quick. It'll just take a sec. Volume. What do we know about volume? This one does not. The volume changes. This is the only one that does not have a definite volume. And the molecules have space to move around. They have space to move around, and they bounce off each other. I'm going to write it, and I'll give you a second to catch up. Okay, examples. Give me one, Dom. What'd you say? I don't know what that is. Is it appropriate?
It was something used in World War II.
Okay. Let's do some common ones that we would all be familiar with.
Wait, what?
Reese? Think about, what do we breathe in? What do we breathe out? What do we see when water boils? Bryson?
Oxygen.
Oxygen is a gas. No, you did not have math homework. Abby? Carbon dioxide. Dioxide. Does anybody know the abbreviation for carbon dioxide? Lori? CO2. Okay, that's an example. Helium is a gas. What do we see when water boils, Kendall? Water vapor. And we'll stop there because there's tons of them, but we're not going to list everyone under the sun, just to give you some ideas. Okay? So you do have homework tonight. It's called the States of Matter half sheet. It looks just like this. Okay? You might need, I suggest you use your notebook, will probably be the most beneficial, but you may also need your book. Okay, guys, you guys aren't going anywhere. We don't have RTI on Friday, so you're all staying in here. Goodbye. Have a good weekend. Okay? So I'm going to pass this out. This is your homework, so make sure under science in your planner you have States of Matter half sheet written down.